Hello friends, in this video we will be synthesizing 1,2,3-benzotriazole from orthophenylene-diamine. Benzotriazole is a heterocyclic compound which features two fused rings, a benzene ring and a system consisting of 3 nitrogen atoms. Benzotriazole possesses wide spectrum of biological activities like including antibacterial, antifungal, antiviral, anti-inflammatory, antihypertensive and analgesic properties. For this synthesis we will need 10.8 grams of orthophenylene-diamine, 11.5 milliliters of glacial acetic acid and 7.5 grams of sodium nitrite. Start by taking 10.8 grams of orthophenylene-diamine in a 250 milliliter beaker. Place a magnetic stirring bar and add 11.5 milliliters of glacial acetic acid to it. Now add 30 milliliters of distilled water and turn on the stirring. Most of the compound should dissolve in the acid. To make everything dissolve, the beaker was gently heated. The solution becomes clear, dark brown in color after the complete dissolution. Now keep the beaker aside. In a separate 250 milliliter beaker, 7.5 grams of sodium nitrite was taken and was dissolved in 15 milliliters of water. Then with stirring turned on in the previous beaker, sodium nitrite solution was added to it in one portion. Immediately an exothermic reaction takes place and the temperature spikes to around 80 degrees C. You can also notice that the color of the solution in the beaker turns to a brighter shade. The chemical equation for the reaction that is taking place is shown in the screen. Nitrous acid is generated in situ by the reaction of sodium nitrite with acetic acid. This nitrous acid reacts with orthophenylene-diamine to form an intermediate monodiazonium salt, which immediately cyclizes to form the product. The contents of the beaker was then allowed to come to room temperature. The beaker was then placed in an ice bath. This will cause the benzotriazole to separate as a viscous oily liquid in the bottom of the beaker. The contents were then thoroughly mixed. The contents of the beaker was then stirred in a lower temperature and this causes the benzotriazole crude product to solidify from the viscous liquid. It was then vacuum filtered and dried. The crude product has a brownish yellow color to it. Next, we proceed to recrystallization and purification of the crude product. For that, the crude product was transferred to a 250 milliliter beaker. Minimum amount of water was added and the mixture was heated. Around 3 to 5 grams of activated charcoal was also added to the mixture. The mixture was then heated for 15 minutes and then it was filtered while it is still hot. The mixture on cooling down solidifies as a white fluffy precipitate and this is much purer product. Since I wanted the crystalline product, I decided to crystallize it again. I filtered and dried the fluffy product and then added water and charcoal and boiled it for another 15 minutes and then it was filtered hot just like the previous step. This time I let the crystallizing dish to slowly cool down by insulating the dish with aluminium foil. When it was cooled slowly, beautiful needle-like branching crystals were formed. It was later vacuum filtered and dried. The yield after secondary crystallization was terrible, 2 grams only. The theoretical yield is like 11.9 grams and the percentage yield was 16% after the 2 recrystallization. Anyway, after 2 recrystallization we were able to obtain much purer product and the crystals were also beautiful, so I am willing to sacrifice the yield to see the beautiful product. So that's all in this video. Hope you have enjoyed the video. These are all my Patreon supporters who are financially helping me so that I am able to purchase new equipments and chemicals required for doing new videos. You can also support me financially via Patreon or PayPal. The links of both of them are given in the description. Once again, thank you for watching. Do subscribe to the channel and click on the bell button for notifications regarding my future videos. Thank you.